Welcome back to the Scotti-BYTE channel, and this is Scott. So if you've been watching the channel for some time, no doubt you have an Incus server, and you've been creating Incus containers and also Incus virtual machines. And so therefore, you probably got your journey started by watching either my LXD containers step-by-step or my Incus containers step-by-step video. And a key part of that was that we created a ZFS storage pool, and by default that ZFS storage pool was inside of a virtual file. So what we want to do today is we want to take a look at that ZFS storage pool and see where the storage is being allocated. So for example, I can do a sudo zpool list here, and it says my default pool has a size of 992 gigabytes, but only 68.8 gigabytes of that are currently allocated. Therefore, the bulk of that is free. The contents of your default storage pool contain things such as your Incus virtual machines, your Incus containers, your profiles, and then also the images used to create containers. And we have a command called Incus Storage Volume List default. The default says list the storage volumes that are in the default storage pool. And in this particular case, you can see that I have a container, I have a couple of images, and 3 virtual machines. So the 2 images are the images that were used to create the containers. In looking at this tabular listing, you can see 3 virtual machine containers and 1 regular Incus container. So we refer to them all collectively as containers. And then here we have a little script that I put together, which will list the space allocation by the various containers. Now, OpenAI is an Incus container and not an Incus virtual machine. And you notice above here how it says that this container is a file system, meaning a files-oriented construct. And so the OpenAI container, being a regular Incus container, does not have an allocated size. Its space simply comes out of the storage pool, and it uses that storage pool area as required. And this particular one has a used size of 21.3 gigabytes. So used size means the total space consumed by the entire data set, container, virtual machine, whatever. That includes the snapshots and any other constructs that are a part of a container, including the metadata. The reference size means the amount of space uniquely held by the container itself, and that would exclude the snapshots. And then sometimes you will see used size is actually smaller than the reference size. And what causes that is the fact that ZFS supports compression, and reference size is reported before compression, while the used size refers to actual disk consumption. Containers and not virtual machines normally use only file system oriented constructs. And so an example is if you want to add more storage or storage that can be referenced by more than one container, you can always do an Incus Storage Volume Create, and I'm creating this new volume inside of the default storage pool, and I'm calling it Test Volume. Now, if I go back and I do an Incus Storage Volume List default, you'll see that there has been a custom volume added that's called Test Volume, and it is also a file systems construct. Let's go ahead and create another container called Test Container, And we'll do that with an Incus launch images :Ubuntu /24.04 test container, and we'll set boot.autostart equals to true, which means that when the Incus server boots, this container will also start. Now that the container is created, let's go and do an Incus shell test container, and now we're in the root account of test container. So I'm going to go ahead and create a folder with the makedir /mnt/test volume. So this does not attach the test volume to that location. It's just that for good documentation, I went ahead and created a folder named test volume. Now I can exit out of the test container and go back to the Incus server level. And the command that we can use in order to attach our test volume to our container named test container is Incus Storage volume attach default, meaning it's the default pool is where we get the test volume from. And then the name of the volume is test volume. That's up here. And then we say test container. That's the container that we just created here. And then we mount it to /mnt/test volume. And then it's mounted. So we can turn around and do an Incus shell into test container and a cd over into /mnt/test volume. And we can do an ls, and of course there's nothing over there, but we can certainly do a touch scott.txt, and that'll create a file over there, and we can do an ls. Now it's not obvious that the file is being stored in the test volume, but it is in virtue of this storage attach command that we did here. And the beauty of this is that you can have 2 or 3 containers that do an attach to the same storage volume, and that in effect means that you can have shared storage that crosses different containers. Containers and custom volumes created with the command Incus Storage volume create, just the way that we did here, are file system based storage as opposed to being block-oriented storage. And the main difference there is that file system-oriented storage does not have to be formatted, and you can immediately access it. Now let's go ahead and create an Incus virtual machine. In order to be able to create our Incus virtual machine, of course, we're going to have to exit out of the test container and go back to the Incus server. So we're going to use the command Incus launch images :Ubuntu /2404, and I'm asking for the desktop variant. And what that means is it means that when it creates this container, it will create an Incus virtual machine with a full up desktop interface. And then --VM says this is not a container, but it is a virtual machine. And we're naming it test VM, and then we're setting boot.autostart equals to true. Now Ubuntu 2404 requires for its desktop a minimum of 2 virtual CPUs and a minimum of 4 gigabytes of memory, and that's why I'm including both of those here. So when I hit enter, it will go ahead and create the root file system. A significant difference of an Incus virtual machine over a container is, of course, it is a dedicated machine that has to virtualize everything, whereas a container shares the kernel of the host. The other key difference is that the storage of a container is files-oriented storage, whereas the storage for an Incus virtual machine is block-oriented storage. To connect to the GUI of our new virtual machine, we can do an Incus console test VM --type equals VGA, and it immediately brings up the remote viewer, and here we are at that desktop. But that's not how I'm going to interact with it, so I'll just go ahead and exit. Instead of that, I'll go ahead and do an Incus shell on test VM, and that will move us into the root account in the shell. So the next thing we can do here is we can do an lsblk, and we'll see that we have block-oriented storage. It has an EFI boot partition, and then it has an SDA disk, and by default, that is going to be a 10 gigabyte disk, and it is 9.9 gigabytes formatted. As long as we have sufficient size in our default storage pool, we can change the size of this particular container, and we can do that by exiting out of the container and issuing the command incus config device override test. I guess it's actually test VM here. Test VM, and we'll say root size equals 100 gigabytes. And it will say device root overridden for test VM. If you move back into it, you would assume that if you would do an lsblk, that it would be 100 gigabytes, but it's still 9.9 gigabytes. And the reason for that is because we'll need to do an Incus restart on test VM, and after it restarts, it will automatically resize itself. So it should have restarted by now. We'll do an Incus shell test VM, and it's not quite up and running. Let's give it one more second, and we'll try again. And there we are. So in test VM, we'll go ahead now and do our lsblk command again. And now, as opposed to 9.9 gigabytes formatted, we have 99.9 gigabytes formatted. One thing worth mentioning is that in order to enlarge the root partition of an Incus VM, that space comes out of the default storage pool, so you must have a large enough storage pool to accommodate the enlarged disk size. Let's go ahead and clear the screen here for a little bit of clarity and do the lsblk command here. And we have that 100 gigabyte disk. And suppose we run out of space later on down the road. So we go ahead and exit out of here, and we do an Incus config device override test VM. And now we're going to increase the root size from 100 gigabytes to 120 gigabytes. But that's going to give us an error telling us that the device already exists. To overcome this problem, we just go ahead and do an Incus config device remove test VM root. And then we can go and do an Incus config device override test VM root size 120 gigabytes, and now it adds the override. And then if I go back into the shell and do an lsblk, it's still at 100 gigabytes. Well, actually, it went up to 120 gigabytes right away. I thought perhaps I might need to restart the container, but in this particular case, it went ahead and resized the size of SDA. However, you'll notice that SDA2 is still 99.9 gigabytes, and that's why we're going to need to restart the container. So then we do an Incus restart on test VM. And we wait here a minute for it to restart. And this time I think I'll wait just a little bit longer before I shell back into it, just to make sure that it's started up. And now I'll do an lsblk, and you'll notice now that the SDA2 has been enlarged from 99 gigabytes to 119.9 gigabytes. Just as a little bit of a reminder, at this point we can go ahead and exit out of that test VM shell, and we can do an Incus list, and we have now a test container and a test VM. The other thing that we can do is we can go back and do an Incus Storage volume list default, and we've gained a couple more images to create containers with, but we also now have the test container, which is simply a file system based ordinary type container. We have test volume, which is a custom volume, and we have the test VM down here, which of course is a virtual machine. And all virtual machines, rather than having a file system, use block-oriented storage. Just as a reminder, once again, if we go back and do a shell into the test VM and we do an lsblk, we have one device named SDA, and we have SDA1 because that's the EFI boot partition, and we have SDA2, which is the root partition. So on a physical machine, often we might want to add a second disk drive, and we can do the same thing with an Incus virtual machine. Let's exit out of the shell for the virtual machine, and then we can execute the command Incus Storage volume create default, meaning create it in the default storage pool, and we had test volume, which was a files-oriented device, but we're creating test volume 2, and we're saying that its type is a block-oriented device, and we're setting its size to be 10 gigabytes. We can't attach a block-oriented storage device to an Incus container because it's expecting a files-oriented device, but with our Incus virtual machine here, we can go ahead and attach this custom storage volume, which is a block-oriented storage volume, to our test VM, and we do that with an Incus storage volume attached to the default storage pool, test volume 2, because that's where it's located in the default storage pool, and attach that to a virtual machine called test VM. And it doesn't really appear like anything has happened here, but if we go into the shell for test VM and we do an lsblk, we now have device SDB listed here, and it says it is 9.3 gigabytes. In order to begin using SDB, like any other block-oriented storage device, we're going to need to create a partition table on it and format a partition. So the first step we're going to do is an apt install on gdisk, and it appears gdisk is already installed here. The next step we're going to do is, since our device is SDB, we're going to do a gdisk/dev/SDB. And then it says, what is your command? And the first command I want to do is an O command, which will go ahead and create a new partition on that. And we'll go ahead and say yes. And then after that, we'll go ahead and create a new partition, and we'll do that and defaults to partition table number 1. And we'll go ahead and just default this, which will go ahead and create it the size of that new disk. And then we'll go ahead and default the hex code, which will be a standard partition. And then we'll go ahead and do a W command to write this out, and I'll go ahead and say yes. It writes the new partition, and now if I do an lsblk, we have device SDB1 here, which is 9.3 gigabytes. Since our test virtual machine is also a desktop, let's go ahead and exit out of here and do an Incus console test VM -- type equals VGA. And then we'll go ahead and barrel through all of these default entries here. And I'll go ahead and make this full screen. And then we can go ahead and come down here and launch gparted. And gparted does not seem to be installed. So that's okay. We can go ahead and launch a terminal with a terminal. And then we'll go ahead and say apt or sudo apt install gparted, and that will install the gparted graphical partition manager. And now that that's installed, we can go down here and say gparted and launch gparted. And of course, gparted asks for the default password, and I don't know what that is here because we are in Ubuntu, but I'm going to figure it's Ubuntu because that's what it sets up for the default machine. And unfortunately, that didn't actually work. So this is the point in time that with our virtual machine, we want to go ahead and create a new user. So we'll do a sudo apt or a sudo add user Scott. And then we'll go ahead and give Scott a password. And then we'll do a sudo usermod -a capital G sudo Scott. And then I will go ahead and log out of this desktop, and I'll go ahead and say log out and log out, and it should give me a username prompt for Scott, which it did, and I'll go ahead and enter my password. Of course, I didn't have to go into the GUI to do this because I could have shelled in here, but I'll go ahead and do a sudo mkfs.ext4/dev/sdb1, and that will go ahead and format that partition to ext4. Now if I come up here and do a refresh devices, you'll notice that we now have a partition that is formatted, and it says that it is has 120 megabytes used and 9.19 gigabytes unused. And if we do an lsblk here, we'll see that SDB1 still shows the way it showed before, but now the partition is formatted. And like any other partition, you could go down and mount it in FSTab, or you can mount it interactively. But presumably, if you have an Incus VM and you have applications running, you would want to mount it in FSTab. If you remember our script from earlier, I had this 2-line script here which printed some headers, and it listed out the used space for our volumes. And this is what we've got right here, and it goes ahead and lists things out, but it's not really the most convenient script. So what we're going to do is we're going to enhance that a little bit, and the way we're going to do that is we're going to install a JSON editor, and that JSON editor is something called JQ for JSON query. And we'll do a sudo apt install JQ, and I'm doing the -y so it doesn't prompt me. On my system, that's already been installed. And this is where you're going to want to look at the show notes, but basically I have created a script here called storage.sh, and if I do a nano into it, it's a storage, it's a script that looks at that storage and formats it and displays it on the screen really nicely. So with the use of that script now, well, actually, once we create that script and we save it out, which will be in the show notes, as I mentioned earlier, it's going to be very important to also do a chmod +x on storage.sh, because you can't execute the script until you give it execute privilege. So I'll go ahead and do a ./storage.sh, and that will run that script. And now we have a very nice display, and it says OpenAI is a container, test container is a container, test volume is a custom volume that is a file system based volume, whereas test volume 2 is a custom volume but a block oriented volume, and that's the one that we used with the VM, the Incus VM. And here you can see that anything that is going to be a container or files oriented doesn't have the concept of allocated space, simply because it is using the storage pool, whereas any block oriented device like a disk for a Incus VM or a custom block storage does have the concept of allocated space here. And so here you can see that our test volume 2 allocated 9.31 gigabytes, and it does have the used space here listed. My VM disk for my desktop 2204, which I have out here as a previous VM's 50 gigabytes. Desktop is using 10 gigabytes. The test VM that we created and expanded, as you'll recall, is up to 120 gigabytes. And then I have a Windows 11 Incus VM that has an allocation of 300 gigabytes. So in summary, this is going to be one of those presentations where you're really going to want to take a look at the show notes, especially to get the details behind the individual commands as well as that script that we just covered. But this gives you a little bit more of a view into how storage works with both Incus containers and also Incus virtual machines, and how you can expand them. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.